Question 22. Solve the simultaneous equations as follows. We have a linear one and we have a quadratic one. So we're going to want to use substitution here. The fact that y is on its own makes it the better variable to substitute for. So we're going to replace y in the second equation with bracket 2x minus 3, close bracket. That gives us this. Once we have that, we're then going to solve the quadratic that we end up with. So our 2x minus 3 multiplying by itself. I'm going to take a 2 away from both sides while we're at it because of the fact that we're going to need an equals 0 for solving our quadratic. Breaking out those double brackets, 2x times 2x gives us 4x squared. We then have 2 minus 6x's, which will give us a minus 12x, and a minus 3 times minus 3 gives us plus 9. Tidying that up, we end up with the following quadratic. 5x squared minus 12x plus 7 equals 0. So to factorize this quadratic, if you can see it by trial and improvement, perfect. If you don't like these types, here's the strategy. AC, we multiply 5 and 7 together to get 35, and then look at the factors of 35. In terms of deciding whether or not we have pluses or minuses, the plus at the end there tells us that we are dealing with the same sign. So both of them are going to be plus or both of them are going to be minus, and whenever you know they're the same, the middle one will give it away. So they're both going to be negative. So I can basically take our 1 and 35, our 5 and 7, put negatives, and see which pair add together to make minus 12. Minus 5, minus 7 does. So what we do now is we take our original quadratic and we split that middle term up into the two pieces involving the factors minus 5 and minus 7. So minus 5x and minus 7x are what give us the minus 12x. After which we look at these as being two halves basically. Take the highest common factor out of the first two terms here, which will give us a, running out of colours here, pink, give us a 5x. If we do that, what we'll be left with inside the brackets is x minus 1. So that's just taking the highest common factor of those two. We basically do the same thing here, except I invite you to write x minus 1. We have to have the same we have to have the same pair of brackets when we take out the highest common factor. And tricky situations like this can arise where your signs don't make any sense, and that's because you would have to take a negative out as a common factor, which is not a natural thing to do. So writing this bracket here in blue first and then figuring out what needs to go here to times these to make those is probably a better play. Once we have that, x minus 1 technically comes out as a highest common factor here, or in other words, it is one of your pair of brackets. And the two things on the outside, 5x take away 7, form the other part. So that's us factorized. We still need to solve. We have this equals 0, so we still need to solve this. Set each factor equal to 0, and then solve the equation you're left with. So that will give us x equals 1 and x equals 7/5. Almost done. That's just got the x coordinates, so I can write 1 comma something and 7/5 comma something. But we don't have the y values, so we go all the way back to our original equation. The thing that we subbed in is the easiest one to plug in to find that. So y equals 2x minus 3. So it's going to be y equals 2 times 1 minus 3. Being aware, you got to write your workings for this. You got to, where is it? It doesn't say, but you have to show all of the substitution you do. Even if you kind of know the answer straight away, you got to plug it in. That gives us minus 1. And then when we plug in 7/5, 2 times 7/5 will give us 14/5. And 3 is the same as 15/5. You can just use a calculator if you want, of course. Give us negative 1/15. So 1 comma minus 1 and 7/5 comma minus 1/15. No, where did that 15th come from? Oops, that shouldn't be there. It should just be a 5th. There we go.